Hi, my name is Mike Holt, and I have to tell you, I'm incredibly excited about teaching this particular program about electrical theory. Most electrical theory programs are called basic electrical theory, and I'm kind of wondering whether I want to call this electricity, but it's called electrical theory. Now, there's a couple of things that I want to talk about as it relates to electrical theory. Number one is like, what is electrical theory? Two, why do we need to do it? Why do we need to know it? And three is when would we apply the concepts of electrical theory? So let's just start from the beginning. Why do we need to know electrical theory? So I'm going to just give my own individual comments, and then you guys can add it. I'm going to ask you guys collectively, individually, what you do. Well, see, the only reason I care about electrical theory, let's be honest here, is because I love the code. I just love the code. I love knowing that there's ways that I can make a difference and make it safer, and that's the whole premises of the National Electric Code. Well, the problem is that when I tried to learn the National Electric Code, when I started, there were so many things it was talking about, I didn't understand anything that it was talking about. And I've learned subsequently, well, number one, you got to know the definitions of terms that the code uses. Number two, you have to understand electrical theory because, see, this is physics, part of it. Element of physics, but then we have the code, which are laws that are trying to accommodate what? Physics and other mechanical things that's involved here. So because I love the code, I need to know theory. Well, the problem was in my experience, as I started teaching the code, I had to explain theory and how it works out. So it gives me excitement because when I'm talking to people and I hear them use the word, well, the armature or the inductor or the reactance or the impedance or, selective coordination or available fault current and all these terms, at one time, I didn't know what they were talking about. So people would be talking about things and you'd read in the code book and use the terms and I was like, I just didn't feel complete. And I've been doing this now for about 50 years and I would say that pretty much I've established my little world in the industry that I'm in the terms that I need to know and the concepts. But see, things are changing and evolving all the time. But no matter how much things are changing and evolving, what really matters is that if you have the fundamentals, then you can spring load into the other concepts. So I'm going to go ahead to Tom. Tom, short version, why do we need to know theory in your world? Because your world is different than my world.
So in my world, I deal from an engineering perspective. If you want to try to help people understand technical concepts, you've got to start from a foundation. So a lot of times we'll generalize, we'll bring in ideas and concepts and we'll relate a technical topic to something that we can all understand because you want to create that bridge for general knowledge. Right?
Well, you guys are developing, you're Eaton, right?
Yeah.
So you guys are developing products. So you have to have conversations about things, right? I mean,
Absolutely.
Some people don't have the knowledge that you have, and they're proposing things or suggesting things.
You got to build off of a foundation, right? So you've got to, it's a building block. I always say, sometimes you can talk over the heads of people.
Yeah.
And then you can watch the light bulb in their eyes go off when you start to get down to some basic level of knowledge that they understand. And then once you see that go off, then you can say, okay, now let's take it to the next level and help you grow as a person in your technical knowledge.
Okay, so you're engineering, Eaton, vice president, whatever it is that you do, and so you're in that world of products, right? Okay.
Yep.
Well, Brian, you're in a different world. Your experience as an electrical contractor. So help us understand as an electrical contractor and also, third generation electrical contractor, my add. You know what I mean? So why do we need to know this? What does it matter?
I think I maybe even have a little bit more personal perspective than being a third generation electrical contractor. And I think a lot of people will kind of share this view. A lot of things for me are hard to remember a thing. Right? And if I can understand what's behind what it is someone's explaining to me, it gives me some way to relate it to like reality. Like, why does this actually matter? Why do I care? Why does this change what I'm doing? And when I have that why behind it, I'm able to actually apply it much broader than I could apply it if it's like you're telling me, hey, just make sure that you make that extra tight right there or use your torque wrench. Well, that's fine, but I'm not going to even remember that comment until I understand why I need to. And you know, so from a slightly different perspective, where you know I've trained a lot of young men to be electricians. You know, we had in-house training programs, and then now being involved with apprenticeship at the level that I am, it's really important to understand the why behind the code. The rules don't make any sense at all unless you can understand why you need the rule. Otherwise, it's just a rule, and then you're trying to find ways to get around the rules. You're looking for loopholes, so you don't have to follow what's in the code until you understand why the rule's there. And then you're like not trying so hard. You're like, you know, I could probably figure out a way to get around this, but really, I actually need to just do this.
Eric, your world is industrial facilities, and you're an engineer, and you know you're the person that's actually working with as an engineer, working with the field people, right? You're getting these things to happen. You know, Tom is designing electrical systems, and he's working with the engineering industry, and he kind of touches it. But you're actually in the field. You're taking the covers off sometimes. You guys are taking a look at problems. What in your world, and what do you see that why it's important to understand the fundamentals of theory?
You know, I love the word. You know, you mentioned fundamental. Tom mentioned the word foundation. I like that. Theory. I have a little bit of a difficulty with theory. Not me personally, but when people talk about theory, a lot of times they say it as opposed to practicality. And so they put it at odds. And so as soon as they hear the word theory, they're like, oh, I'm not interested in that, because it's kind of like, whatever, it's imaginary, whatever. But, you know, you said fundamental. Tom said foundation. I like to think of a concrete slab, you know, in the construction field. That's what we need. We need the slab before we can build the building. And, you know, Tom mentioned about talking over people's heads. That's equivalent to building a building without the foundation. And so you see the light come on in people's eyes. You have to know what the words mean. You have to know what the concepts are. And it's more than theory. Brian talked about bringing things together. And so what we're doing is we're bringing the fundamentals, we're bringing the foundations together, giving us a basis for understanding, so that then we can go on from there.
Well, I get phone calls. Hey, Mike, they're getting shocked at the boat dock. You know what I mean? What can I do? And it's like, the person doesn't know anything about theory. He actually doesn't know anything. I mean, he knows how to dig a trench. He knows how to put the pipe or the cable in, make the connection, maybe even comply with the code, okay? But he doesn't understand the utility distribution generating facility, the transmission lines, the wiring of the utility systems. Well, Mike, I'm getting 38 volts from the washing machine to the concrete floor. And I'm like, I can't help them because I know the person doesn't know theories. I can't explain to them, well, here's what happens when you open your neutral and you have your neutral conductor connected to the, I can't even help a person at all. And so by having the foundation theory, like you just said, we can all start, we can like, oh, you know what, I hadn't thought about that. That's a good point. What I'm going to do is I'm going to do this and I'm going to do that. Yeah, now you're on it. Okay, call me after you check this out, because explain about a voltmeter. I don't know what a voltmeter is, doesn't know what he's measuring, doesn't know why it's a voltmeter. He just goes through mechanical world, which has to be stressful. Mario, tell us about you. You know, your background is you're a second generation electrician. Your father, you know, you moved into the inspection world. You know what I mean? But you started at a young age. I mean, without knowing theory.
Yes,
Okay,
yes.
Go ahead. Tell us why you think it's important for these.
Well, like you said, my recent profession before coming to work for you was as an inspector. So I'm really into laws. So what theory does for me is that it establishes laws. There's a Ohm's law. There's a Lenz law. There's different laws in theory that really set the stage for you to understand code rules. To Brian's point, he likes to know the why. I also like to know the why. And what theory does for me is that it breaks things down to the most littlest level. We start with the atom, like Mike says, and then we build from there. So theory is just super important for you to get into become an electrician, an engineer, an inspector. You have to know theory.
Mike,
you're going to feel empty otherwise.
I just get a call. Mike, the inspector says that I'm putting in these baby protections at swimming pools where they core holes in the concrete and then they put these little metal sleeves and they put the plastic in there and they stretch it. And the inspector says that I have to run an 8-gauge bond wire and connect to each of those metal poles. if you don't know theory and you read the code, you might think that that would be a good idea. But if you know theory and if you know the code, you realize, well, the last thing you'd want to do is actually energize those poles, because the electrical system is never safe. And now purposely connecting wires, plus mechanically, how do you have this out there and run a wire? And how do you screw mechanically this wire and connect it to this pole? And you can't even have a conversation with a person because they actually believe it's safer. Because as an inspector, we're going to get into the code book vaguely, but we'll just allude to it. 90.4 in the code, and of course this is not a code class, says the inspector can waiver rules as long as it says something in there, that it's safe. Well, if you don't know theory, and you're struggling with, well, do I bond these poles or don't bond the poles? And you watch a video, MikeHolt.com/pools, and you're like, okay, I understand what that means. Of course we don't bond the poles because you have to apply rules and the inspector makes those decisions, but it's a safety issue. It isn't a matter like, well, it had to be strapped within 12 inches and it's strapped within 13. No, this is like, well, do I bond that? Do I not bond that? What's the advantage? So to me, putting it all together, it is so cool. It makes you feel great. You understand what's going on. Let's get going. First thing, I want to take a moment to thank God, giving me the opportunity and the skill to make a difference in the lives of so many people. And I want to thank each of you right now. You know what I mean? Tom, Brian, Eric, Mario, for helping me, because this video was designed for people who know nothing about electricity, might not even be in the electrical industry, might be wondering about getting electric, or getting into it and wondering, I don't know if I should want this or not. So let's get going. All right, first thing, I love the code. Sorry, just the way I am. And the NFPA has what is called the standard NFPA 70. And what's the purpose of this document? See, what's the purpose? All right, number one slide is the purpose of the NEC is the practical safeguarding of persons and property from hazards arising from the use of electricity. It's not intended as design specification or an instruction manual. So if you were like me, if you were in the electrical trade, you opened it up and say, okay, I'm going to learn the code. And you're like, after 10 minutes, you realize, whatever I read, I don't even know what I read. And because this is not design, this means that, theory. It also means that you've had some practice and you've learned and you're working in the field. So now watch this. This is practical safeguarding. It doesn't mean that if you do an electrical system and you comply with the code that it's going to be safe. Just like you drive a car with airbags and seat belts, does that mean you're going to be safe? Of course not. People get killed all the time. However, it's practical. We got seat belts, we got airbags. We do the best we can. So that's, by the way, if you notice this, which we're rarely going to do this, is you'll see a graphic with a number on the top. If it doesn't say theory, that means it's from the National Electrical Code, which we're not getting into, but just want you to know how we tie in and what we're doing. Now, 90.1c, if we went into the code book, we could look that up, says this: the NEC, which is the National Electrical Code, addresses the safety principles, principles, contained in the IEC standards, such as, Tom, what's the IEC standard? Because the code is saying, hey, it contains the safety principles of the IEC. Mm-hmm. What's the IEC?
That's your international standards. So I can't remember the acronym. International Electrical
Commission.
Commission. Yeah, I don't know if it was commission or council.
Now, Eric, you work worldwide. So,
Yes.
so is this an organization that establishes basic principles and then the individual countries adopt those principles and then they create their own individual codes?
Yes, it is. The IEC standards are I'm thinking Geneva in terms of the library of IEC standards, and so they're international.
But you know what? Guess what? It doesn't matter what standard. Like I always say, you'll see later on, electrons don't know the difference. You know what I mean? They don't know. So we're going to start with electron, but what is it? It has to do with protection against electric shock. Bingo. Adverse thermal effects, heat and explosions. Overcurrents, meaning we're going to learn what overcurrents are later on. Fault currents, we're going to learn what fault currents are, whatever they are. Overvoltage, we're going to learn what overvoltage is going to be. So let's make a note, guys, that on the very last slide, when we get done with this whole program, that we can look at this slide like, oh, I now understand what 90.1c is talking about what we're trying, the safety principles. We just want to make sure that we don't kill anybody. Okay, so what are the safety principles? Well, we want to protect against fires, protect against electric shock, electrocution. Now, electrocution means that you're dead. So you can't say, well, I was almost electrocuted. Well, I guess you can say you're almost dead. You know what I mean? But you weren't dead. So electric shock, electrocution, arc flash, and arc blast. We're going to be talking about, in other words, so protection against fires. Let's get to that one. Well, here's just simply very common receptacles that have any kind of receptacle, but a receptacle that has some electronics inside there adds another level of complexity to electrical systems, becoming more and more complex. And you can see right here that this is melted. Now, I don't know exactly what's going on, what caused this, and later on we can talk about these kind of things. Maybe we can add this slide later on, Mario. Well, maybe the loose terminals, maybe there was a failure of the equipment, maybe there was over voltage conditions, things can happen. But the thing is, the code is considering these factors that things can happen and we can have a fire. And Eric, you said it one time many years ago that the National Electric Code is that you design systems and you install it and you inspect it so that when it fails, right?
Right.
Because it is, go ahead and say how it goes.
Right. Yeah, nobody really, I mean, it's easy to design a system to work, but our job is to design it such that when it fails in such a way that doesn't harm people or set fires.
So that's what but we got to know how you harm people, how you set fires, what the
Right.
heck happened, what do we got to do here? Okay, fire, well, here's some simple basic things. Mechanically, you put a couple wires under a terminal. Okay, well, I had to get the 3 wires there, and there was only 1 terminal, so you put them under. The problem is later on you'll realize, and we'll talk about that, well, that terminal wasn't designed for 3 wires. It was designed for only 1. So the physics work out that 1 wire, 1 terminal, tighten a certain way, and then it's been tested for a specific application. Because if you don't, then there's going to have a chance of having heat develop, and we'll talk about that later on. So that's not something that should be happening. Here's an example of mixing copper and aluminum. Right. Well, number one, we have dissimilar metals, which is never a good thing anyhow. But this terminal was not designed for 2 wires, and it wasn't designed for 2 wires. And you can see right here, the electrician, let me see if I can zoom in on here. Okay, move that over there. Cut it off. That's called what, guys?
Haircut.
Called a haircut.
Haircut.
It was never designed that you're going to be cutting some of the strands off. But listen, if you don't know theory, you're just saying, well, I was just trying to get that thing into the connector. That's all I was trying to do. So, and I'm not going to ask people to raise their hands in this room who's done a haircut. So, because nobody's ever done that. So we know that. And I never did that either.
Not on purpose.
On purpose. Well, we can't even say that. All right, let's just go on. Protection against shock and electrocution. We're going to be talking about electric shock. I'm not going to get into the details, but just understand some basic, let me go back here. Some basic components is that you have a transformer, you have a person, you have a light. We're going to protect electric shock. Here's some slides. Soldier electrocuted in Iraq was negligent homicide. I was involved in that case in Iraq where a special forces guy just went to take a shower and he got killed because the water heater pump motor failed. And then there was other failures subsequent after that. Here's a unlicensed electrician admits regret at the boy's electrocution's trial. It was just a simple young man just going out there to a bus bench, sitting down, waiting for the bus to come by, and it had rained. It was in Florida. It was actually down in, I guess, Coral Gables, down in Florida. It's in Miami area there. And he died, a 14-year-old young boy. Here's a young girl. She just was just working in a swimming pool. Actually, it was her very first day. And she went in the pool to just check the chemicals, and she grabbed a handrail, I guess to a ladder or handrail, and she put the other end, they kind of get the chemicals in. In the process, there was a difference of potential. What the heck does that mean? Well, we're going to be talking about that. So she got killed in a swimming pool. See, by knowing theory, then we can make sure that we install it to the code so that it's going to be safe. And another one here, young boy Michael Sloan. I was involved in all these cases here. North Miami Beach, he just jumped in the pool, swam to the other end of the pool. He got to the other end of the pool, that's where the light was. He got killed. He died before he never got out of the pool. Okay, now we're talking about protection against arc flash and arc blast. Understanding principles. Watch how cool this, let's say, it's cool. Okay, this is not a real person. Maybe I can get a better video. But watch. There's a person standing in front of a piece of equipment. I think, I don't know what it is. I don't know what it is. I can't say what it is. Watch what happens. Listen. Electricity is dangerous. You know, like everything has a double-edged sword, right? You have all these advantages, right? You got the bright side, the light, and then you have the dark. So we need to understand, yes, we're going to talk about all the fun stuff and all the exciting stuff, but we need to understand that this is a very dangerous industry. You got to understand what an arc flash is, what an arc blast is. And we're going to be covering all that. Circuit breakers. Let's continue on. Here's an example of having equipment that's not compliant with the code, not compliant with product standards, and you can see it completely disintegrates. Here's another little video. Watch what happens to these wires. I think this is really cool. I'm not going to say anymore. Just watch what happens to the wires when there's a fault condition. You can see they're still up in the air. What is going on? And that is a big deal, because if that happened to wires while it was inside of equipment and the equipment wasn't designed for that event, well, then those wires are going to pull out of the terminals. They're going to be wrapping all over the place, you know, and so we need to understand theory. The scope of the program, well, we're really not getting into voltages and that kind of stuff, but we're talking about fundamental electrical system. We're not talking, this is not about high voltage utility distribution systems. This is not talking about, on the other side of the decimal point, the electronics. This is talking about theory that relates to practical wiring of buildings and structures in accordance with the National Electrical Code. But we are going to get into the utility system, because if you don't know how utility systems operate, and if you don't understand how the electronics operate, well, then we're kind of losing it. So we're generally talking about basic electrical systems here.